Well, hello there again, friends. Today is 2/9/2022, and today is the Odin Project Vlog Day 57. And today, picking up where we left off, we're on immediate and advanced array magic. Besides being a quick and handy way to store data, arrays also have a set of functions for manipulating that data in a very powerful way. Once you begin to master these functions, you'll start to see ways to use them all over the place. There are really only a handful of these functions, but as you'll soon see, the possibilities of what you can do with them are near endless. And then they have two videos, basically by this guy named Wes Boss. He's that JavaScript 30 dude. He has a couple videos here that they take you through. Doing some these advanced functions with array methods. Highly encourage you to watch them on your own. It's good stuff. And then you get down here to practice, and it starts out pretty honest. It says you've been through a ton of content, and it would not be surprising if you were feeling rather overwhelmed with this at this point, which that is so true. I feel pretty overwhelmed. Even though it doesn't look like it on my videos, I feel probably look pretty well put together and polished, but I'm a learner just like all you guys, so learning as we go. Let's take a little time to slow down and practice this stuff with more coding exercises. I'll warn you now, some of these get pretty difficult, but if you've done the lessons, you should have covered everything you need to know to solve them. Don't be afraid to go back and review if you find you can't remember something. That's part of the process. If you get stuck, come join us in the chat room. And they're referring to the chat room as the Discord group. So it says at this point you just need a little more practice. Go back to the JavaScript exercises that we introduced in Fundamentals 4 project and complete the following. There's calculator, palindromes, Fibonacci, get the titles, and find the oldest. And I got through calculator, and I got halfway-ish through palindromes, 3/4 of the way through, and it got hard really quick. I was trying to see if I could crank that one out for this video, and I just decided it was time to stop. So today we're just going to go over calculator, which isn't as bad as I thought it was going to be. There's only one part I really kind of got stuck on, and we'll go over that now. So here's calculator. This is the spec file. So going through, well actually first, before we do that, let's go over to, okay, this is the palindromes. Let's go to the JavaScript exercises. Sorry, I forgot about bringing this up. I try to have all this up beforehand, but that's alright. So here we have the exercise 8 calculator. The goal for this exercise is to create a calculator that does the following: add, subtract, get the sum, multiply, get the power, and find the factorial. In order to do this, please fill out each function to your solution. Make sure to return the value so you can test it in Jest. To see the expected value, take a look at the spec file that houses the Jest test cases. Mouthful. Alright, so this is the spec file for the Jest test. So first thing we're going to be testing is addition, and there's 3 of them. Add 0 and 0, add 2 and 2, and add any positive numbers. And they're going to throw 0, 0 in there, 2, 2, and 2, 6. So to make that work, we're going to bring in a function with num1, num2, and we're just simply going to return num1 plus num2. Just simple as that. I had some internal calculations going on. I deleted it because it was such a simple function that you don't really need it. So I had let sum equals 0, and I had sum equals 1 num1 plus num2, and then return sum, but that you don't really need all that. So same thing here for subtraction. Num1 num2 returns num1 minus num2. And that subtraction section is right here. It's just one test. Subtracts 10 and 4 to get 6. And then we have a sum section. This one I had to dig in a little bit, and I ended up, this is the one I got stuck on, and I had to go to the solution. So this is exactly what they have in the solution. But what it's asking you to do is we're getting into arrays now. And on this one, these first couple were not arrays. Now it's an array. So you bring in the array parameter. I mean, it can be anything, but array is self-explanatory. And it's a sum. And so the sums are going to do all this. The first test is computes the sum of an empty array. So empty brackets to be 0. The next test computes the sum of an array of one number, sum 7, or excuse me, the array of 7 to be 7, and then it computes the sum of an array of two numbers, array index, array of 7 and 11, excuse me, and they want you to add that up, and then also add up a bunch of arrays, 1, 3, 5, 7, 9. So that's the sum section. And this is how it works out. I'm going to try my best to describe this. I don't 100% fully understand this myself right now, but it's a work in progress. So we have a return statement. So all this line, that basically the return statement is the entire line, because we're going to get the so what we're going to do here is we're going to get the array, and we're going to use the reduce, I guess you'd call this method maybe, or function maybe, I don't know. Anyway, you do use the reduce, and what the reduce does is basically, this is a very clean and short, succinct way using the arrow function to not only create and declare a function, but also to create a loop, a for loop inside of that function. It basically, it's pretty sweet. So it takes basically like 6 lines of code and puts it into one, especially if you use it in this manner on a return statement, because this particularly works. So what that does then, like I said, the reduce does the looping. So it's going to take parameters of total and current. Again, you can make these up. These are whatever you want them to be. So it just it makes sense to have total and current. So total will be your running total that you loop through. Current will be the current iteration of the number that you're on. And then the arrow function is, and then this is going to be the evaluation inside of the anonymous function here, is total plus current. Mathematical operation, there's that addition. And then the best way to explain the 0 at the end is that when you initialize this loop, total will be 0, and because we put that there explicitly. If you didn't have this, you'd actually get an error and you'd fail the second and third and fourth test. Basically anything that had to take on a total value, basically any other than one number. Because if you remember, in a for loop, or while loop or anything really, you have to initialize your variable. So total has to be initialized somehow to 0. So if you don't have this in here, there's nothing to initialize. So total comes back as undefined, and you get an undefined and then an error. So that's why that 0 is in there. So basically, to round that out, that's what that does. So we're basically creating the arguments of parameters here, total and current, and we're adding total plus current and looping through, iterating until the array is complete. So total is going to be is the parameter that is going to be incremented, and current is the current array value being evaluated. So if that makes sense. So that there solves the sums. So you have 0 or an empty to be 0, so it'll be 0. Sum will be 7, and then these work because we aren't defining anything in the array. We're defining the array right here basically as empty parameter, and then we have the array.reduce, which just turns it into an array and performs that reduce function that we just described. So that's that. And then the next section is multiply. We have multiply down here. We're going to multiply two numbers, and we're going to multiply several numbers. And so there's just two tests in this one, 2 and 4, and then 2, 4, 6, 8, 10, 12, 14. Multiplication. And so the multiplication is going to be the same type of concept, so I won't reiterate it here, but you're going to have num1 and num2 is what I put there as initializers, parameters, and then the arrow function, and then we're going to be evaluating num1 times num2. So the only difference is this doesn't have a 0 because it doesn't need it, because as I mentioned earlier, the total is initialized up here. We don't need an initialization here because num1 is only one value and it never changes. Well, actually, it does change. That's interesting. You would think that wouldn't work. So first number times the second number. So, but it's a series and an array. I don't know. I'm not sure on that one yet. Let me know in the comments if you guys know why that works without 0, because it does. I'll show you here in a minute. Anyway, we'll go ahead and skip over that. So you go to power, and this is test the raises one number to the power of another number, and it's just one single test. And we're going to raise 4 to the power of 3, and you should be getting 64. And how you do that is so simply is a double asterisk. I did look up the solution to this just to see. I actually Googled this one. This is how I got it. So there's two ways to do this. You can do double asterisk here. That would be that's shorthand for power. Or you can do the math.pow function, which I think is the or method, if you will. I think that's the one that's shown in the solution file. But this one's just cleaner and simple. Both get the correct answer. So if you did math.pow and then put these in parentheses, that would be fine too. And then we have factorial. This is the last part. This one gets kind of sketchy. I did have to do a little bit of Googling on this. I didn't look at the solution file, so I'm proud of myself there. But we have factorial tests, computes the factorial of 0, 1, 2, 5, and 10. So just to reiterate, let's see. I think I Googled. Or is this all part of the palindrome stuff? Yeah, I was working on the palindrome, so I may have gotten rid of it. Oh no, right here. So the definition, actually, I mean the definition is in here. No, it's not. So I had to look it up. Okay. So the definition is basically integers represented with letter n. A factorial is a product of all positive integers less than or equal to n. So basically, if the number is greater than 0 or 1, it will be factorial by the multiplication of each number leading up to that number. So in this example, 5 would be 1 times 2 times 3 times 4 times 5. So they want you to code that up. So how you do that is not too difficult. So you have basically a if and a for. And the if is a test rule to see if you have 0 or 1, because like I said a moment ago, if the number inputted by Jest is a 1 or a 0, we're going to return a 1 because it's only factorial by 1, because 0 is factorial by nothing and 1 is only factorial by 1, which is 1. So there's no other possible answers for that. So if and that's an or pipe. So if either of those, remember in JavaScript, the or pipe doesn't mean like our worldly or, like you get ice cream or cake. It means that either one of these can be true or both can be true. So basically, in this instance, if neither of these are true, it's going to come down, skip that, and it's going to come down to the for loop, and we're going to have an iteration here. Let I equals num minus 1, and then I is equal to or greater than 1, and we're going to increment down. We always usually increment up, but this instance we're going to increment down because we're wanting to, we need to increment down because we don't know how, because we don't in front, before the values entered, we don't know how high we need to go, so we can't start at 0 and go up. But because the number given, we got to go down to factorial down to 0, so we know we need to go down. And that's why it's incrementing down, and that's why I is equal to or greater than 1, incrementing down. And you have that test there is because of this right here. Because if it evaluates down to 1 or 0, it's no longer it's either the factorial is done, or it would, excuse me, it would be a 1 and it wouldn't have even gotten there. It would have stopped here at this if. I kind of over-explained that, but so let I equals num minus 1. So that helps us increment down, and then there's your evaluator, and then there's your incrementation down. And then the expression is num equals num times I. So we're going to be, that's where we're going to be getting our num to increment in value by multiplication to get that factorial completion. And then at the end, when it's done looping, we're going to return num, which will be the sum of all the loops combined. Whew, that was a mouthful. And that works. So that will work for 0, 1, 2, 5, 10, and really any number that you put in there. So just to show you here, I'm going to go ahead and run the command. So you're going to run npm space test space calculator dot spec.js. So if you run that, it's going to take a second, and 16 passes, 16 total. 16 passed. So there you go. There's all the green check boxes, so we're good. And that's good. So like I said, I got to palindromes, but I didn't finish it, so we'll pick up on that next time. So anyway, that's all for today. Hope you guys enjoyed the journey and you come along for the ride tonight with me. And please let me know in the comments what you think of that digit in that back here in the code. If you can work it out in your mind, if you can tell me in the comments why is not putting 0 in here works, but you have to put it in here. So let me know in the comments if you guys work through that in your mind, or if you have it on your code. Let me know in the comments. So other than that, as always, with that said, until next time, see ya.